Hello everyone and welcome to This Week in Net. By the way, that's the radar display that we have in all of our offices. This is an episode already close to Christmas. Christmas is just around the corner. And this week we're going to talk about hardware. Hardware is such an important part here at Cloudflare. And for those who don't know, Cloudflare has a global network that spans more than 330 cities in over 120 countries. And it interconnects approximately with 13,000 networks. That means that interconnects with major ISPs, cloud services, and enterprises. It's important to note that over the last 2 decades, hardware innovation has evolved to meet the demands of modern technology. For example, CPUs lay the groundwork for personal computers and early internet infrastructure, while the rise of mobile devices drove advancements in energy-efficient ARM-based chips. But on the other hand, GPUs, initially designed for graphics, have become critical for AI and machine learning, excelling, for example, in parallel processing and powering advanced data analysis, such an important part of 2024 and chatbots. As Cloudflare unveiled recently our Generation 12 hardware, let's explore how these advancements are making a difference. I'm your host, João Tomé, based in Lisbon, Portugal, where I am right now. And with me, I have Syona Sarma, Head of Hardware Engineering. On to the episode. Hello, Sayona. How are you?
Oh, I'm good. Nice to be here. Really excited to talk to you about Gen 12 and what's coming from a hardware perspective in the future.
Exactly. A lot to talk about. Before that, can you tell us a bit of your background? Where are you based? Where are you originally from? A little bit of your background.
Sure. So I lead the hardware engineering team here at Cloudflare. I've been here about 2 years. I'm a hardware engineer by training, worked at Intel, my first job out of college, in a bunch of different roles that ranged from CPU design to business and product from an Intel data center business perspective before coming here. We have a wonderful team of hardware systems engineers, and the team's responsible for the design and development of the next generation of servers, which we think is critical to all of Cloudflare services. It powers all of the new features and developments from a services standpoint.
In a nutshell, that's it, right? For those who don't know, can you explain us a bit what is Gen 12 and why does it matter, really?
Yeah, every time we think about building a new generation of servers, which we do about every 18 months or so, because we're trying to keep up with the industry and the landscape in terms of new CPUs available, new memory and storage technologies available. We have 3 goals. The first is how can we deliver better performance and power efficiency to our customers? What new features can be introduced? What new functionality can be introduced? The AI inference capability is the one that we went with this last round. And finally, reliability and quality, which is very important for us to be able to run a global network and for customers to be able to count on us from a security, privacy, no incident perspective. Those are the 3 goals we look at with the larger understanding of the cost of infrastructure, which is usually the biggest CapEx expenditure for any company that owns its own hardware infrastructure. So we have to keep that in mind as we make some of these design choices. So with Gen 12 specifically, what does Gen 12 deliver versus the prior generation? So the 3 metrics that I talked about, we're able to deliver 2x the performance, which we measure in terms of requests per second. Cloudflare runs web workloads, which are basically 20% of the internet's traffic. So our workloads are varied, and it's a really fun challenge to be able to characterize these workloads and determine what the hardware requirements we need to build towards need to be. So we start out by characterizing the workloads. With Gen 12, we were able to deliver 2x the performance versus prior gen through a couple of different methods. The first being the CPU choice itself. We went with AMD's Genoa X product, which has a larger cache, which we discovered during the workload characterization process, a DDI5 capabilities, PCIe Gen 5, adequate network connectivity given our edge network spans so many different colos, including remote regions. And finally, we wanted to make sure that the performance is tuned well enough to meet the workload requirements. So we are able to deliver 2x the performance in terms of requests per second. We're able to deliver 60% better power efficiency compared to Gen 11. Why is power efficiency important? We find that our customers in Europe and Asia actually value the power efficiency as the highest KPI because of the cost of power and the cost of electricity in some of these regions. Not to mention sustainability goals that Cloudflare has taken on. Stay tuned for what's coming towards the end of the year in terms of an impact report related to power efficiency. It's also really important from a rack density perspective, which basically means the more servers you can squeeze into a rack that is rated at a certain power level, the less the data center expansion costs are. So, it ties back to the cost perspective. So performance and power efficiency, number one. Number two is the featured capabilities of Gen 12. So as of last year, you might have read on some of our blogs, we launched a product called Workers AI, which has the inference capability. We decided to expand upon that in Gen 12, listening to what customers were telling us about where the landscape is evolving. The key feedback that we got was we want to be able to support better throughput on smaller models and larger models. And we're able to do that with the GPU attached on Gen 12. We call that a turbo SKU that is able to meet these requirements. We're also a security-first company, so some of the feature development focus for us is what kind of security features in terms of, we have something called the secure control module, disaggregated root of trust, OpenBMC capabilities for better board management. These are things that we keep in mind when we think about what the new generation of servers should be capable of. And then finally, the reliability and the quality aspects. We run about a 3-quarter qualification cycle and make sure we're adequately testing for. We understand the error rates of the components. We understand resiliency requirements, which vary by workload, and are able to deliver a reliable, resilient infrastructure to our customers. So these are some of the capabilities that Gen 12 offers.
So several points. You mentioned several points. For those who are not familiar with that term, AI inference, why is that important for AI specific for AI use case, like chatbots, our interaction with chatbots or other models? Someone is building something on top of a model somewhere in the world. What does AI inference, have a good AI inference in a way, means for those folks?
Yeah, so when we started thinking about AI, there are so many players in the market. We started thinking about what can Cloudflare do that's different from everybody else. And the answer was clearly that we already have this global spread of edge infrastructure. How can we increase the capabilities of our existing infrastructure, given our system constraints, to introduce some sort of AI capability, right? And the path forward for us was inference because it requires lower power. And typically, given our spread of the network, power and space from a data center perspective is a huge constraint. We don't build giant training clusters. We chose not to build giant training clusters and instead go the path of a workload that requires better latency and benefits from being closer to the customer from an eyeball latency perspective. We've proven that better eyeball latency and being able to optimize for network latency is a superpower that Cloudflare has, given the global infrastructure spread we have. So leveraging that, inference workloads was clearly the answer on what we would be able to have a competitive advantage in. So we started out by a points of presence strategy, trying to make sure we had GPUs all over the map, closer to the customer, because latency and throughput are the two measures that people look for when it comes to inference. As we went along, we realized that we need to be able to support larger models, for which we need larger GPUs, which again ties back to what is the power envelope that you can accommodate in a system constraint that you're already given all of the edge workloads that you're supporting. So we have now 2 generations of servers, one that has sub 100-watt inference cards, and another that has high power GPUs that are capable of supporting 70 billion parameters and so on. We're not done. We're looking at how the landscape is evolving, and our strategy with AI continues to be to understand what workloads we would like to target and show a benefit to our customers on, and how that translates to hardware. We might go the ASIC route if we decide that there is a specific segment of workloads, say image generation, that we want to be better at than anything else. If stream workloads are something we want to be able to combine with inference, we might go a different route with disaggregation of GPUs, where we pool a bunch of GPU resources to be able to support the larger models as well. There are a bunch of experiments, a bunch of POCs that we're planning for the future, and I know we'll talk about that in just a second, to be able to keep up with what's happening in the AI inference landscape. In my mind, the biggest win for us has been to be able to segment the market that we want to go after and not try to do everything at the same time, which allows us to leverage the benefits that Cloudflare already offers.
Makes sense. You mentioned a lot there. One of the use cases I typically find more interesting is a lot of us interacts with chatbots, and the how quick they respond to us is really important by now. If they're a little bit quicker, we'll do more work, we'll be more effective potentially. If it's really slow, it's not a good experience. So the latency, how quick these models work, it's even to the general audience that uses chatbots is important, of course, for those building the apps also. But it gives the total landscape of those using AI, those creating platforms over AI, will have a better potential in a way with better latency, even when something needs more computing power as AI needs, right?
Yeah, definitely. And the trade-off that we make with delivering better latency or throughput is power, right? So the challenge really from a hardware perspective is from a mechanical and thermal point of view. How can we accommodate the extra power that GPU-like hardware consumes on a large global scale? We want every system to be capable of running these workloads. So how do you trade that off with performance? Which is why we've taken kind of this two-tier strategy of we have GPUs everywhere. Now we have a new generation of servers with high-power GPUs, and we do a lot behind the scenes in terms of traffic management and routing and optimizing for network latency to be able to deliver response times that you're talking about, which customers really see at their end.
In a way, I'm showing right now the Gen 12 servers in specific with some captions showing where is the CPU, where is the memory, where are the fans. Any thing that you think some of these images show us that could be interesting to share with the general audience? Most folks don't have like a visualization of some of these servers. Here is one. In a way, they are put into racks. A rack could have several servers, right?
Yeah. So just to give you a sense of what our rack power limits are, they range from 8 kilowatts to 15 kilowatts. So they're not super high power racks given the places that we have a presence in. So you'll notice we're very open about our designs. It's kind of a Cloudflare way of doing things to be able to share our learnings and learn from our partners. So one thing you'll notice here is we're committed to open standards. So DCSCM is basically, it stands for Data Center Secure Control Module. It's something we worked with the OCP team on, the OCP work group on, in developing first to market the 2.0 version of it. So one thing that you can see clearly here is the dedication to open standards and open architectures. I would expand this to what's coming in the future in terms of open architectures such as ARM. We are exploring a bunch of ARM solutions to see how best we can integrate Cloudflare acquired capabilities with maybe an ARM type architecture. I think we'll still stick with x86, but add to that, right? So I would say from a hardware perspective, the commitment to open standards is one thing you'll see here. The other piece of this is the effort that it takes to be able to go through the hardware selection process. And what I mean by that is, what type of CPU do you choose? How much memory do you need? How much I/O do you need? What is the ratio of the core to cache to memory to storage? These are the aspects that our engineering team looks at very closely, given the larger constraint of power and the fans and the cooling solution that we're capable of integrating into our data centers. As you mentioned, this is a node. We put several such servers into a rack, and we make some design choices at the rack design level. An example of this is moving from a 1U chassis to a 2U chassis to improve the workflow and also to be able to design for the future. When I mentioned inference and you want to insert a GPU, you need to have the leeway to be able to do that in a design that is not going to have the GPU for a year ahead, right? So we're really designing for the future. How do you keep the flexibility of new workloads that you need to support? How do we keep our commitment to open standards? What is the design criteria, and how do you balance the needs of the workloads with the costs of building a new system, primarily around power? You'll see all of that as you read through the blog. And we talk to you about the challenges that we faced and how we've chosen to address them.
Sure. I was mentioning something that we're showing visually, but those hearing will have to read the blog to see some of the images. But you mentioned DCSCM before, something that also improves security and the need to be aware of open source projects and what's coming. You mentioned ARM. Can you give us a glimpse on some of the things that we did to put this efficient, this Gen 12 efficient, reliable, working properly?
Some of the things that we did to enable Gen 12 or what's coming in the future?
Maybe starting with the enable part, and then we'll address what's coming in the future.
Yeah, I mentioned the three metrics that our goals were power efficiency and performance, feature improvements, and finally the resiliency of the network, right? So we designed a system. We started out by looking at the hardware landscape in order to be able to select the right components, starting with the CPU and being able to tune the CPU to our workload needs, looking at the memory technologies, storage technologies, and building the right configuration for the system that could deliver the performance improvements that our customers demand. In addition to the power efficiency aspects, so one of the things that we've done is look at it from a rack level and understand how we can standardize our racks so that the deployment is easier for our downstream teams. We partner very closely with capacity planning with our InfOps, infrastructure operations teams, and our sourcing partners to be able to have supply diversity and also to be able to deploy these systems as needed, where they're needed, as quickly as possible. So a lot of the rack level design criteria was a thought exercise in designing Gen 12. Finally, the cooling solution, which will continue to be something that we're focused on in the future generations, is becoming more and more important because the CPU TDPs are going through the roof. The CPU we chose for this generation was 400 watts. The next generation is about 500 watts. And once you cross that threshold, you start to think about liquid cooling like technologies, if they would benefit us longer term. So it's kind of leading us down the path of how can we expand our capabilities and still keep power at acceptable limits given where we operate.
Makes sense. You mentioned already specific elements on the thought process of selecting Gen 12, the different areas, including the design of the rack specifically. But I'm curious, and a lot of changes have been happening in the hardware space because of AI, as mentioned. What is the Cloudflare perspective regarding hardware? and also how it evolved in the last 2 years, for example. Is it different now than it was 2 years ago?
Yeah, I think the AI landscape has made it such that we can't accommodate our design changes in the typical hardware product lifecycle. So what I mean by that is it takes about 18 months to come up with a new generation of server designs, right? But with AI, you need to be able to respond quicker to the market because the needs are changing at a much quicker pace. What that means is when we build a Gen 12 system, for example, you have to think through what's coming with all of the uncertainty around it and figure out how to build that flexibility into your system design to be able to accommodate and pivot and integrate new capabilities along the way. I would say that's one big change in terms of our mindset of hardware design. The other thing that we've focused on for Gen 12 and will continue to focus on for Gen 13 is modularity. So our servers support compute, they support storage workloads, and now they support AI inference, right? So is there a better way to manage our infrastructure more efficiently and make it more modular and be able to give the workloads that need more storage, and the workloads that are more compute bound, lesser drives? How do you enable this modularity in a system that looks the same wherever you deploy it, which is one of Cloudflare's philosophies, that every server should be capable of running every workload, right? So modularity is another aspect of design that I think will be reinforced with Gen 13. Just to give you some example, a glimpse into what's coming in some of the experiments we're running, we're looking at methods like disaggregation, where we're able to pool the storage resources, pool the GPU resources, and use them where we need them as we need them in collaboration with our software engineering teams, where we were able to route the requests where they need to go and do a lot of the optimization behind the scenes. So it'll be really interesting to see what comes out of some of these experiments and what that will feed from a Gen 13 perspective.
For sure. I'm curious on the element, and I remember last year we actually did some episodes here in This Week in Ed regarding that, about having our data centers worldwide being what we call AI inference capable. So they were capable of doing AI inference, as we mentioned before. How was the process of having most of the data center by now, a lot of them with GPUs, with this Gen 12 capacity, with better AI inference latency in a way? How was that process that it's by now over a year, much more than a year, right? How was that process specifically? Deploying that?
It was an evolution, and we learned a lot along the way. Like I mentioned, we started out with sub 100 watt inference cards because that's what we thought we should target when we first started down this path. We went with NVIDIA GPUs because they were the simplest to deploy, both from a hardware and software perspective, right? So we tried to deploy them globally everywhere we could. What we learned as we went along from our customers is we need more performance on larger models and better throughput on smaller models in certain cases. So that led us to create a new generation of GPUs, which we integrated into our Gen 12 systems to be able to support that. So it's been an evolution as the landscape evolves and the workloads evolve. We've been integrating that and trying to deliver servers at a much faster pace than we would have otherwise. So it's been kind of an interrupt, which we're able to do because we own our own infrastructure. We see this as a reason to continue to invest in hardware at Cloudflare and continue to build our own hardware systems instead of renting instances, because it gives us the ability to be able to pivot and move as the workloads change around us.
Makes sense. And for example, for those who don't know, we have like a lab in Austin, right, where we test all of the things. Can you guide us through a bit of the process of having the lab, of deploying to the locations? Can you guide us a bit on that process and what the lab is like?
Yeah. So our production environment is, given that we run all types of web workloads, it's really hard to benchmark for each type of hardware solution that we're testing, right? Because what benchmarks do you choose? Does it reflect adequately what your production environment looks like? So the lab environment is critical for us as a staging environment. It's where we take all of the new hardware solutions available in the market and determine what the right fit for our specific workload needs are. We have a tech readiness phase that we go through. We're in the midst of that for Gen 13 to understand what are we projecting in terms of the workload needs growing over the next 5 years, because that's how long these servers stay in our fleet. Can we model that in our lab environment, try to benchmark them before we put these systems in production for more adequate and thorough testing as part of our qualification cycle? So typically our qualification cycle includes a tech readiness phase, an EVT, DVT, PVT phase, and finally mass production. And tech readiness is where we make the decisions on the exact configuration for the system that we're planning to build, then work with our ODM partners to be able to build that along the way and intercept our qualification cycles that I just mentioned. So it's critical. I would also mention we're running a bunch of POCs in our lab related to disaggregation, related to liquid cooling, related to more changes in our architecture that would allow us to use our infrastructure more efficiently. We want to prove these out in a lab environment before we can put that in production. The last thing is, I mentioned we're looking at alternatives to GPUs, possibly inference accelerators, to know which of these suit the workload needs, what we're really trying to target. All of that testing is set up in our lab. We call it an AI jungle gym, where we're testing and trying to make sure we know what exactly we need before we move forward with integrating that into our production. So
that's a good name. Can you repeat the name? It seems cool.
Yeah, it's called an AI jungle gym. We started out calling it the AI playground, but jungle gym seemed more apt given the different types of experiments that we're running there. So
that's a cool name.
Yeah.
Specifically, we have several blog posts in our blog. We already mentioned one of those. There's also thermal design supporting Gen 12 hardware, cool, efficient, and reliable, and also analysis of the epic 140% performance gain in Cloudflare Gen 12 servers. In any of these blogs, is there something you want to highlight that folks should take a look and learn more specifically?
Yeah, I think the thermal aspects of the design are increasingly important. So if you want to understand some of the challenges we're facing and how our thermal team is tackling them, the thermal design blog is super interesting. I would also refer you to the design blog of Gen 12 if you want to understand exactly what we use in our infrastructure and why we use it. I think there's a lot to share and learn with the community about future hardware development.
Regarding looking ahead to 2025, what excites you and worries you the most? What is your prediction in this topic of hardware for 2025?
What I'm looking forward to is the changes from a hardware architecture perspective that we can make to make our designs more modular and more flexible. Because I don't think we know exactly what the future looks like in 5 years. And we want to build hardware and systems that are capable of serving the infrastructure needs at that point, right? So the flexibility and modularity aspects is a very interesting challenge that we're working through. And what can we do from a hardware perspective, from a thermal solutions perspective, to have a solution that is capable of whatever is to come in the future? It's a really interesting thought exercise. We're in the tech readiness phase and we'll be able to implement it in Gen 13. So really looking forward to the architectural changes of Gen 13. Also on the inference accelerator space, what can we do better? What additional capabilities can we integrate into our infrastructure to continue down the inference path? Is there an adjacent area, kind of like training elsewhere, running inference on Cloudflare? Can we create an end-to-end data pipeline and prove to customers the value that inference on Cloudflare brings, in addition to just being able to run inference as a workload. Inference is not a workload you run in isolation. It's really a feedback loop. So if you're able to provide an example of a full end-to-end data pipeline of training through inference with our R2 solution, which, by the way, is super important for inference type applications, I think it will be a big win. These are some of the experiments and POCs that we're engaged with, which you'll see in the next year.
Regarding AI in particular, you mentioned already some of the flexibility needed to accommodate the changes that could be around. If you had to do some predictions on what those changes could be in terms of what the hardware landscape will suffer or not regarding AI, what would that be? Do you plan that it will continue to grow a lot and changes will be needed regarding hardware and AI?
Yeah, I think it's anybody's guess at this point. What my sense of things are that the parameter count of the models will cap out around 100 billion parameters. We see a change in the precision needs moving towards lower precision, which could mean smaller hardware footprint in terms of compute capabilities, memory, and so on. And in-memory compute as some of the things that we see with the newer products that are being launched. All of this with the focus on power efficiency, right? You hear a lot about more power efficient AI architectures, which I think is critical given where the GPUs have been going in terms of the TDPs and the demands on power that not everybody can accommodate. So these are some trends that we're seeing with AI. We'll pick and choose what makes the most sense for Cloudflare workloads, and our future roadmap will address some of those.
Before we go, I'm curious on this more general question, which is, first, if you had to explain what excites you the most about hardware and why is this area so interesting for you, how would that explanation be in a way?
Yeah, I think hardware is foundational to everything Cloudflare does. Obviously biased as a hardware person, but as a hardware team, we have to think ahead before anybody else starts thinking about some of these problems because our product life cycles are so long. Software has a quicker turnaround so that our product teams and software engineering teams can introduce a new feature in a quarter or 2 quarters, right? But if you don't have the hardware capabilities to support that and deliver the performance our customers need, we're not going to be competitive. So being such a critical part of the infrastructure team and being able to deliver this to our product and services teams to enable them to build new things and new features is super exciting. And I have a wonderful team of hardware engineers here at Cloudflare, and we're working on doing that over the next few years.
For you, what's the potentially you already answered this, but I'll make the question the same. What is the one thing about hardware that most people, even if they're not technologists, don't realize, but they should?
I think the impact on the environment, given that the power of hardware is continuing to rise, is a serious concern. And we have some sustainability goals as a company that we've taken on and we're making slow progress towards. So I think that's something that people may not completely internalize, especially with AI and machine learning on the horizon, right? What does it mean in terms of compute power, in terms of the carbon footprint and the impact on our environment from a sustainability perspective? I see it, I don't see it as something that's bleak. There is a focus on power efficiency and power efficient architectures, both from an infrastructure cost savings perspective, but also from how can we reduce the impact on the environment, and what types of new technologies and energy solutions can we look at. There's a lot happening in this domain that I think people would find interesting to learn more about.
Makes perfect sense. And you already mentioned in a way hardware, it's core to the cloud. So cloud is hardware also, and you showed us a glimpse of that hardware perspective related to the cloud that we all use, that allows all of these interactions, critical infrastructure interactions as well, in terms of what you need, like planes, airplanes, etc. So it's quite interesting to get a glimpse of all these hardware perspectives related to the cloud and how things work, and AI is definitely relevant there for sure.
Yeah, really looking forward to what's to come in 2025. Please read the Gen 12 blog if you want to understand the technical details of our hardware systems. And we'll continue to share what we learned from some of the experiments that we're running in our labs today.
Absolutely. And there's a lot to explore in those blogs for sure. Thank you so much, Sayona. And that's a wrap.